myclass.com.
Dear students, our new topic, linked list, a linear data structure. What is a linked list? Linked list is a linear data structure in which the elements are nodes stored at contiguous memory locations. The elements in a linked list are linked using pointers. We have already discussed all the basic things about arrays. We all know that the arrays are like in memory, it is in contiguous memory location. The first element, and in the very next memory location, second element is there, then third element is there, and it is based on the type of the data or type of an array. If it is any character array, so this is the first address, and in the second address, the second element should be there. So that is array. But when we are going to linked list, if let's consider it is our memory, this is our computer memory. In this memory, if we are talking about an array, the elements like this 4 contiguous locations, the array's element should be there. But in linked list, the elements are not in the contiguous memory, not in the contiguous memory location. Maybe the first element should be here, second is maybe here, third is here, and fourth is here, not in the contiguous memory location. So because of that, we want to know about if one is here, one should be this element should be aware of where is the second element. In array, the second element should be in the next memory location. According to our type of array, we can easily calculate in which portion or in which address the element, which address the third or fourth element is there. But for a linked list, it is difficult. So because of that, the element is also contains, or maybe the linked list is also contains the detail of the second or very next element. That means the address of the next element. So the element 1 should knows about where is our second element, the address of the second element. So for that we are using pointers, we are linking the nodes with the pointers value. Okay, so this is the difference of array and linked list. So in simple words, a linked list consists of nodes which each node contains a data field and a reference to the next node in the list. We can say that in linked list, we are called it as a node. So in this node, one data part is there. Also one link part is there. Data is to store the data element and link is to store the address of the next node in that particular linked list. Clear? So the data means each node of a linked list can store a data in a data field, and each link of linked list contains a link to the next node. That is the two important terms of linked list. Data and link. Next, representation. Linked list can be visualized as a chain of nodes. We can visualize a linked list like this. Every node point to the next node. So when we are comparing to an array, if A is an array or A is an integer array, the first element A of 0 is in the base address. Is it? So maybe the base address is 1000. Let's assume base address is 1000. So this array is starting from the address value 1000. So that 1000 value is stored in a variable, in a memory location, in a memory that holds 1000 value, 1000 address value. Okay, like that, where is our first node in that linked list? This is our node 1, this is our node 2, and this is our node 3. So the address of the node 1 should be saved in a pointer variable head. And so n1 is the first node. We can direct it through this address value. In this node, 2 fields are there. One is data field and other one is next field. That is the address of the next location, next node. So N2 is the address of the N2 is stored here. So when we are visiting a first node, we can easily we easily finds that where is the next node. So hence we have reached here. So here the data field is there, the node to data field, and next node is the address of the our next node, node 3. If in this example n3 is our last node, is it? So the last node address value or link part is pointed to null value. Null value means this node 3 is our last node. Understood? So that is the difference between array and the linked list. So linked list contains a link element called head first, or we can in some algorithms it is termed as start also. Okay. And each node carries a data field and a link field called next. A data field to store the data, and the next link field is to store the address of the next node. Each node is linked with its next node using its next link. Last link carries a link as null because that is the last node to mark the end of the list. Clear? So this is all about the basic information about a linked list. Types of linked list. Singly linked list. First type is singly linked list, doubly linked list, and a circular linked list. So singly linked list means item navigation is forward only. In this picture we can easily understood what is the speciality of a single and doubly linked list and also the circular linked list. So in singly linked list the navigation is in forwarded only. So the first node, the head node, this head part is contain the address of the first node, and the address part of the first node is contain the address of the second node. Like that this is going on, and the last node address part is null. Okay. Like that singly linked list is working. Doubly linked list means it can navigate it forwarded and backwarded in both direction. So the node contains 3 parts. The first part is for previous node address, and second part is for data, and the next part is for the next node address. So three portions are there for each node. So in the first node the previous address value is null because this is our first node, so there should not be a previous node, and the data part and the link to the next node. So let's assume that this is our N1 and this is our N2, N3 and N4. Okay. So it contains null value here and N2 here. So N2 contain N1 here and N3 here because the previous node of the N2 is N1 and the next node of the N2 is N3. So N3 contains N2 as previous node address and N4 as next node address. In N4, N3 should be here and the next value is null because this is the last node. So this is the speciality of doubly linked list. So circular linked list, circular singly linked list, we are discussing here the circular singly linked list. So the only difference when compared to singly linked list is the last elements of the singly linked list is null. Is it? But in circular linked list it contains the address of our first node. So this is our first node, second node, third node and fourth node. So N2 here, N3 address value here, N4 address value here, N1 should be here because the last node is pointing to the next very first node. That is the circular singly linked list. Now we are going to array versus linked list. So an array is a collection of elements of similar data types. We have already discussed about it. A linked list is a collection of objects known as node, which each node contains 2 parts, data part and the address part. Array elements store in the contiguous memory location. Linked list elements can be stored anywhere in the memory or randomly stored. Array works with a static memory. That means in the very first we are declaring like A of 10. A of 10 means we want 10 memory locations for this array. That means we are declaring it first. We are here static memory means that the memory size is fixed. The 10 is fixed and cannot be changed at the runtime. But the linked list works with dynamic memory because we are only first created the structure of each node, and in the time of running we are dynamically allocating or we are dynamically creating memory for each node. Okay. So dynamic memory means that the memory size can be changed at the runtime according to our requirement. Okay. Array elements are independent of each other because for first element is does not knows about the details of the second elements. Basically it is in the next memory location, but the elements should not hold any information about the second element, but the linked list elements are dependent on each other as each node contains the address of the next node. So to access the next node, we need to access its previous node. Array takes more time while performing any operation like insertion, deletion. And compared to linked list, array takes more time. Linked list takes less time. Accessing any elements in an array is faster as the element in an array can be directly accessed through index. The deletion insertion operation is complex when compared to linked list for array, but the accessing an element is easy when compared to linked list because we can access a very easily like a of 1 like with the index value, but accessing an element in a linked list is slower and it starts traversing from the first element of the linked list because we want to traverse from the first element because only the first element contains the address of the second element. Maybe we want to traverse the third element, but the second element only knows the address of the third element. Clear? In the case of an array, memory is allocated at compile time. We have already discussed here static memory like because in the compile time when we are declaring an integer array like a of 10, that 10 memory location or 10 into 2 because the integer length is w equal to 2. 10 into 220 memory location should be allocated at the compile time. But in the case of linked list, compile time there is no memory allocation at the compile. Only at the runtime memory is allocated in the case of the linked list. Memory utilization is inefficient in the array. Because of this concept, the memory utilization is inefficient. For example, if the size of the array is 6 and we have already declared and the memory should be allocated at the compile time itself. But array consists when at the runtime we are only entering 3 value. We only want 3 elements for addition or some other operations. So the other 3 memory locations will be unused. Okay. But memory utilization is efficient in the case of linked list because the memory allocation is performing at the runtime. So we want to do or we want to perform an operation with the 3 data at the runtime. 3 nodes should be allocated. The memory for 3 nodes should be allocated. Clear? So that is the difference between array and linked list. Hope you understood the concept and thank you.